Welcome to another episode of Decoding Chemical Engineering. We are here today with Mr. Muven, who is a chemical engineer and currently pursuing his PhD down in South Africa. Thank you so very much, Muven, for being here with us today. We are very happy to have you with us, and we have lots of questions to ask you about your education, about your PhD, and about your future career. But before we begin, can you kindly tell us a little bit about yourself?
Yeah, thanks, Hamza. So, yeah, I think it was a good introduction. I think besides my academic work, I'm also a lecturer here at UCT. Started off with what we call an MQA post, a Minerals Qualifications Authority post, which they sponsor younger academics to get into the teaching and research space. So besides being a PhD student as well, which I guess now is my priority, I'm also a lecturer for the undergraduate students. And generally, I've been interested in engineering for a long time, even as a child, because my father was an engineer. I just like being in the technical space.
Thank you so very much for being here. And like I said, we have lots of questions for you and to get more information out of you about yourself and about chemical engineering. So let's get the ball rolling. So the very first question we would like to ask you, and I think you have answered it before in the very beginning, but what brought you to the world of chemical engineering?
Yeah, so I think I mentioned engineering already, but specifically for chemical engineering, as a school student, I was either going to be mechanical or chemical engineering, and that was because I was very into cars at the time, and I wanted to get into it. But also, I guess at the time the media was focusing a lot on climate change and how fossil fuels were going to run out. And this was before fracking started, so I was heavily invested into renewable energy. So I thought, go the chemical engineering route, and look at how we can find an alternative fuel for cars, basically, for automotive transport. And that sort of cemented my chemical engineering choice. And even into postgraduate studies, that's sort of the direction I took when making that choice as well.
Specific purpose that you chose to pursue, and then you chose chemical engineering out of it. That's very interesting. A lot of people don't get that laser sharp, like they never identify that passion that they have. But it's great that you chose chemical engineering to pursue that path. Because what I would like to ask you now, of course, is that chemical engineering can be defined in many different ways depending on where you're working. And in your case, you are more interested in finding the renewable fuel for cars. How does chemical engineering fit into that picture? Like, in your own opinion and experience, how would you define chemical engineering then?
Yeah, so I think that was my view years ago. Right now, I think my view has changed a little bit. The world has definitely changed as well, and the landscape in South Africa is not what it used to be for chemical engineers. So, my definition of what chemical engineering is at the moment is probably not focused too much on myself, but I would say it's more or less a multifaceted discipline that uses fundamental and empirical knowledge and the scientific method, as well as process engineering. So, focus on process engineering rather than chemical engineering to solve highly open-ended problems. So I think the highlight there is that, unlike mechanical or civil engineering, my observation is that many of our graduates are more versatile in whatever industry they end up in. Anecdotally, in the last 10 to 15 years in South Africa, the jobs for traditional chemical engineers have declined, and our refineries have closed down. The last two, I think not last two, but two of them this year. We've only had 5 refineries. So, the chemical engineer is not going into that old space. The mining space is still quite there, and they take quite a large number of chemical engineers as well. But generally, they're venturing out into different industries, such as finance, data science, automation, and so forth.
Yeah, I fully agree. Like you said yourself, many people are now continuing into non-core, non-engineering professions like finance, economics. So it's always great to know that there are so many options after you get your degree, and you're not limited to just process engineering. So I guess that's always a good thing.
Yeah, no, definitely, it's always a good thing. And I mean, although most of the people who I speak to, who I've studied with, and even the students right now, they still want to get into the normal chemical engineering spaces. So like into fertilizers, pharmaceuticals. Yeah, I mean, maybe less so the petrochemical space, but now it's into biochemical, synthetic fuels, those kinds of things. So it's still, I mean, yeah, the interest is still there. It's just that it's now broadened into the non-traditional spaces.
Exactly. Yep. Thank you for that. Well, then let's move on and talk about your actual chemical engineering education background. If you were to go back to when you were doing your bachelor's, because chemical engineering is considered to be one of the hardest degrees, and a lot of people complain that it has one of the highest workloads, because just like you said, they are very versatile, but that versatility comes with a price that you need to read a lot of books on many different topics. So going back to your experience in bachelor's, how was the workload in general throughout your undergrad?
Yeah, so I mean, I've had friends in other disciplines as well, and from what I can tell, from what they tell me as well, it is, as you said, one of the most difficult degrees to work through. On average, I was spending 10 hours a day working, whether it was trying to learn material or going to projects. And I mean, the undergraduate life, it focused heavily on the theoretical background as well. So there were practicals, and there were a lot of self-study parts as well, and assessments, but it was intense. And I mean, part of the reason why it's so intense, specifically in South Africa, is because I think of the longer vacation period, so that cuts down on the amount of time that you have to focus on work as well. So I mean, for example, if you didn't do the supplementary exams, then you would have about a month and a half, in some cases 2 months of vacation. And yeah, you were supposed to do vacation work experience, but the requirement was only about 6 weeks. So yeah, I mean, it was intense.
Yeah, I can imagine. So did you specialize in a specific topic while you were doing your bachelor's?
So at the time when I was doing my bachelor's, there weren't too many specializations out there. It was focused heavily on petrochemical or mining. And occasionally, if the numbers were high enough, it was in pulp and paper processing. But specifically for me, I did a synthetic fuels stream coupled with a biorefinery stream. So it's quite mixed. I wouldn't say the focus, but those were the streams that I took.
So was there a specific reason that you chose to continue in this field rather than anything else?
Yeah. So as I mentioned, because of my passion for cars as well, and also for renewable energy, that's why I chose the synthetic fuels route. So it's a little bit different from the extractive petroleum processing route, rather, because with synthetic fuels, you don't necessarily need fossil fuels. You could derive that from biomass as well. And then for the biorefineries part of it, yeah, I mean, that's just, again, emphasizing on the point of my interest in renewable energy.
Amazing. It's really nice. But for example, if you work with process engineering, that tends to be a lot more mathematical based. Sometimes you can end up getting those hard hat labs in the classes as well. In your case, now that you were working more focused on the environmental aspect of chemical engineering, did you feel that was it more mathematical based or was it more lab based that you had to work with?
So in my undergraduate studies, I think about 80% of the work was theoretical, so mostly mathematical based, but there was a big practical component as well. So yeah, I mean, we found ourselves in safety booths and our hard hats as well for those for that part of. I mean, I think the current trend is that we're looking more into data science and trying to incorporate that into the undergraduate curriculum. That's across South Africa. So more and more we'll see, the drop in the practical side of it. But I don't think it's going to go away completely. So yeah, there'll always be that aspect of, having to have that practical experience.
Exactly. Of course, I mean that thing can never go away because you cannot really learn these theoretical parts of it either unless you really see things in front of you. Now we have a few more questions about you going from your bachelor's to your PhD. And then to begin with, how has your experience been so far transitioning from going from your bachelor's and then going into as a PhD student?
I think the transition was actually quite jarring. On the one hand, it was exciting because you're entering this new space, and specifically for me, I was moving from one side of the country to the other, to UCT, which is, I mean, everyone knows that it's the best, at least in South Africa, they know it's the best university in South Africa. So that was the exciting bit. The not so exciting bit, and I guess a little bit scary, is that the structure that you have as a postgraduate student is quite minimal. Besides a few courses, you're on your own with the help of your supervisors, and you have to forge your own path. Versus undergrad, where you know exactly what deadline you have at a certain point, what the requirements are for an assessment, and sometimes it's just down to sitting for an exam. But here, yeah, I mean, although you have certain requirements, it's much less structured. And besides that, something which is not often mentioned is that in undergrad, if you're used to working with your colleagues, or even just talking to other people, it's much more difficult to relate to other people once you're in the postgraduate space. You might have similar topics, but very often you find yourself alone in what you're doing, and that part just completely falls away. So you need to be, let's say, you need to be focused, and it's much more difficult to be able to talk to other people to figure out your way.
That's a very nice observation. But could you tell us a little bit about the PhD project that you're working with right now? Like, what are you researching on?
So I'm specifically working on, I think I'll mention the title. So the title is Process Technologies for the Recovery of Biobutanol from In situ and Ex situ Separation. And it's got that name because I'm looking specifically at the fermentation of sugar into biobutanol. And biobutanol, well, about 10 years ago or so, was supposed to be, or was claimed to be, the next great biofuel because it could replace the current petrochemical fuels like diesel, jet fuel, or specifically more so gasoline. So there was all the rave about it, and would be much better than ethanol as a biofuel as well, because you wouldn't need to modify your engines to run with it. So the problem with this process, or the process of making biobutanol, is that it's extremely energy intensive. It's one of the big problems. And you would have to recover it via distillation through the traditional route. So my project was focused on looking at new technologies that would be integrated with the fermentation to draw it out while it is being made. So the idea is that if you do it while it's being drawn out, you will allow the bacteria to continue fermenting the sugars, and that would make the process more efficient in that way. And also, if you have an energy efficient method, it would reduce the overall energy burden of the process. So thereby making it more economically feasible, and also being able to actually use it as a fuel rather than having more energy go into making the fuel.
Amazing.
Yeah, so I hope that sums it up.
It does. Yep. So that's quite interesting that you're working on that. But if I was to ask you, how did you get your PhD, the very research topic that you're working with, how did you end up coming across it? Did you apply for it externally, or did you get it through a professor already in your undergrad?
So for myself, I had approached a number of people with interest in the specific topic. So for butanol production, or biobutanol production rather. And after chatting to a few people, a few prospective supervisors, then I landed at UCT under the supervision of Professor Sue Harrison, and there was sufficient scope and interest in the research group. So we took it from there and formalized it into a project. Typically, you have posts which are advertised, and sometimes you are approached by professors to take on a new project. But in this case, yeah, I mean, I ran with a it was something that I was interested in. I approached a few people and then eventually landed where I currently am with this topic.
Okay, thank you. But if I was to ask you, because for the students out there that are very interested in applying for a PhD later on, what would you say are like the basic requirements in South Africa? For example, if someone was to apply for the very university that you are doing your PhD right now, what are the basic requirements that every student should fulfill before being eligible to apply to be a PhD researcher?
So, should I give the answer as a broad?
Yeah, of course, like a broad general requirements that there are.
Okay, yes. I mean, generally in South Africa, you would need some research experience, and we often take that as a master's. So, the general approach is to apply from your bachelor's to a master's, and then from there, if there is enough scope, it can be upgraded to a PhD. Alternatively, you would do your master's, you'd finish it, and then after that, you would apply for your PhD as well. So, when looking for topics as well, I mentioned there were three ways. You either look for advertisements from your respective universities or the universities you're interested in, or a professor can approach you as well if they see that you're working in a specific space and they could take you on. That's often from working with them or having those conversations with them, whether at a conference or online as well. And then lastly, if somebody was very passionate about projects, they could approach somebody as well. So it doesn't matter which university. It's most people are completely open to things like this, especially passion projects. And if there's funding, then it can be taken from there. So that's the route. I mean, from a bachelor's, you apply for a master's. And even during that application for the master's, you can express interest for a PhD, so that if you want to, you can scope it for a PhD, and at some point you would upgrade it from a master's to PhD.
Okay, amazing, thank you. But because like let's say there is an undergrad, you would really have to plan it very early on in your education tenure that you have to go for a PhD, right? Because deciding that you want to go for a PhD in the final semester, that doesn't really give you that much time to prepare yourself. Because normally, many students, they have that option to do research projects with the professors. But what would you suggest for the students? How can they approach professors, and how can they prepare themselves before going for research projects to really brush up their chemical engineering skills, and what skills you keep at the back of the mind?
Okay, so I think just to understand the question, it's about what sort of experience would they be looking at as an undergraduate student, maybe in the third or even in the second year.
Exactly. Yep.
Yeah. So I mean, if they're interested in doing a postgraduate degree at that point, I wouldn't say it's necessary, but it would be useful to approach a professor for what we call vacation work in some research topic. And very often these are available. You might not always get what you want, but going into the lab sometimes or working with the data, doing that literature study at that time or literature review would definitely help when you're applying for your master's or your PhD. It will also tell you, whether you actually like to do this. If you don't like to do it, at that point you would know, this is not for you. And if you do like it, then you take it to the next step. Like, what topic are you actually interested in? Is working with this person, is it constructive? Do you like to do it? And that's what I would recommend. So approaching a professor while you're an undergrad, whether you're second year or third year, I wouldn't recommend it in first year. And maybe not so in final year as well, because it's extremely intensive. And I think most people will find it difficult to balance the research courses that they have to do as well as the design courses as well. So, I mean, that's my advice.
Okay.
Approach a professor for that experience.
Perfect. Thank you. Now, normally, what I have heard from some different people is that if you're going for a PhD, it's a good idea to do your bachelor's and then do your master's and then get some industrial experience in the middle, just so that you get the industrial practical know-how of engineering, and then go for a PhD, because then you would have the realistic constraints on what you're working with. What has been your take on that? Is it necessary to do industrial work before going for a PhD, or if you go directly for a PhD, is that more beneficial?
So I think there's no one size fits all answer here. In some cases, if you're heavily interested in academia and not so much on the practical side, then it might be better for you to just go from a bachelor's to a master's and then to a PhD. If you're focused on a topic that is widely used in industry, and you're interested in getting this technology out there or whatever output from your work into the industry as well, then I would recommend going into industry and getting that experience. Whether it's done before or after your postgraduate studies is going to be dependent on what you want out of it. So I think in general, it's much more difficult to leave university than it is to go to the working environment and come back. And it's because again, it's that structure and being in that location again. So focusing on your work rather than clocking off at a certain time if you're having that type of job in industry. So it's a very different mindset. And I would actually recommend if you have a bachelor's and you're interested in doing postgraduate study, go for that master's. If at that point, maybe a year down the line or even 6 months down the line in your master's, you feel that you want to continue this type of work, whether it's in the same topic or not, then you stay on and do the PhD. Otherwise, if you're not feeling it as well as you hoped you would, go to industry. And I say do the master's first because you get that experience of having to work on a topic by yourself. If you go to industry and come back, it's much more difficult. And from the conversations I've had with other colleagues as well who've done the sort of thing, they'll tell you the same thing. It's much more difficult to go from industry back into studying, even if it's a postgraduate study or degree.
Interesting. Yeah, that is a very interesting point. Thank you, Muven. But then let's talk about your PhD tenure and exactly what you're doing at your PhD, because you have, of course, kindly told us that what it is that you're working with. But how long is a PhD in South Africa?
So I think the minimum is 3 years, depending on which university you go to. But it generally is 3 years long from start to finish. So if you're upgrading from a master's to a PhD, depending on where you've applied for that upgrade, that will also it'll also include the registration of that master's degree as well. Because technically you wouldn't graduate with that master's; you'd only graduate with a PhD. So in that way, it will be shorter if that's your intention from the start. Going from a bachelor's to a PhD. The other route, which is I think the more typical one, is where you do your master's for 2 years or so. And then you would do the PhD for 3 to 4 years. But anecdotally, it takes longer than the minimum time. Most people will not finish it in less than 4 years. Whether they're upgrading it from a master's or starting afresh.
Okay, and is there like a maximum time that you need to finish it under?
Not that I'm aware of, but there are other constraints. Your interest in the topic, your motivation, as well as the funding that's available for it. I think also, to some extent, there's also the relevance of the research. If it's something that other people are working on, you run the risk of the work being published, and then you lose the novelty. So novelty is something that's it's required in your PhD, the output of your PhD, and unfortunately, if somebody else publishes the same work or something similar, then it's gonna be much more difficult to continue with it.
Of course, yes, of course. Because of course, when you're doing a research, it really has to be uncharted territory that you're out there to explore. If someone has already done it before you, then there's no point of you doing the same thing, right? but that's great. But then, if I was to ask you, but how long have you been doing your PhD now?
So I think I registered in 2017 for the first time. That was from my upgrade. So it's been, unfortunately, it's been 6 years. But one of the reasons for that is that I did take up the lectureship position as well. So it technically makes it, doing it part-time. Although it is my priority right now, it is very difficult to do it as a part-time degree. So yeah, I mean, that's my journey as well.
Mm.
I hope to finish it by the end of this year. Likely there will be some revisions, or maybe not, and then graduation will be next year. So that's my current aim. And if it all goes well, I mean, I don't see any stumbling blocks along the way this time.
Yeah,
amazing. I'll be a doctor by next year. So yeah, I mean, that's the approach though. So generally, if you focus on your PhD, that's the only thing you're working on. It will take you about 4 to 6 years, depending on what the topic is, what errors you run into, what needs to be redone, and so forth.
Okay, great. But then if I was to ask you, because as a PhD researcher, I mean, you have a lot of balls in the air when you are doing your PhD. You have to handle one task and one from another. There's a great deal of multitasking. So if I was to ask you to describe, how did a typical work week look like for you as a PhD researcher?
Okay, so I mean, it is going to vary depending on the topic as well. But I mean, just like any work week, you would start off generally in the morning. It depends on the rules of your departments and your research group. And if it's lab work or lab-based as well, it's going to depend on what resources are available, the scheduling of those resources as well. So, I mean, if you're doing an analytical project, you're using the HPLC or the GC or things like that, then you're going to need to work around those resources. It's not very often you're assigned your own one. I mean, it is rare and it does happen sometimes if you're lucky, but that's going to be difficult. So that way, I mean, just like a normal work week, you start in the morning, finish in the afternoon, and you would tend to do your experiments in blocks. So for my topic, when I did do experimental work, there would be a lot of planning before you do the experimental work. So perhaps a week, 2 weeks, just by your desk, sitting with a computer, preparing your experimental plan. And then over the 2 weeks, there would typically be a meeting with your supervisor. Okay, so at least 1 or 2 meetings with your supervisor to approve of this experimental plan. And if your research group does have it, you would have a discussion group, so a broader meeting with more input, and with those who have more experience in the experimental methods to give you more guidance before you get into it. Okay, so once that 1 to 2 weeks or so is done, you would then spend, depending on what experiment you're running, the next longer duration on those experiments. So again, it's going to be a long duration thing. Unfortunately, if you're in the biochemical space, these experiments can run overnight sometimes. So you need to prepare for those sort of incidents. But I mean, in general, you can avoid those most of the time. So again, it would be from like 8 to 5, working in the lab, doing those experiments, and then not necessarily going home, but going and analyzing it and see what changes you need to make for the next day. So that would carry on for about a period of maybe a month, or 2 months, or even up to 3 months, depending on how many runs you're doing and what matrix of experiments you have. If it's simulation based, it's going to be the similar thing. You'll have about 2 weeks or so of preparing your plan of simulations to do, what type of modeling you use, what software you use, what techniques, where you get your data from, and so forth. And again, you meet with your supervisor, go to your discussion groups and get more input. And then instead of the lab, we'll just be running those simulations in those times. I think most research groups as well across university, or rather most departments across universities in South Africa, have a requirement that you need to teach in the undergraduate space. So you typically, schedule time to be a tutor, an assistant lecturer, and those types of things as well. So yeah, I mean, yeah. So the work week is actually quite packed, and if you're disciplined, you get through these things and you work through the problems rather than letting them go on. And the number of problems actually is quite significant because of the nature of the work. You're going into an exploratory space. You don't know what's going to happen. So you need to be aware of these things and have that contingency while you're doing this. Otherwise, it can throw you off.
And I can imagine you had a very packed schedule. But like you said, mentioned yourself, many times you also have to work as a teaching assistant or as a professor while you're doing your PhD. And can you tell us a little bit more about that? When how far do you have to be on your PhD to be eligible to become a lecturer or a professor on the side?
So the rules vary depending on where you are in South Africa. A few years ago, there was a requirement that you have to have a PhD to become a lecturer. Before that, you could do this as a master's, or you could do this with your master's alone and perhaps some industry experience. But more recently, you have to have your PhD or some level of let's say, progress in your PhD to apply to become a lecturer. So, yeah, I mean, this is going to be dependent on where you are in the country and which university you're at. So at UCT currently, it's, dependent on how much of progress you've made in your PhD, perhaps 1 or 2 years, and evidence to show for that. So maybe a publication, a conference proceeding, that sort of work, and to have a plan to show that you're going to finish it and what you need to do to finish it. Yeah, I mean, so those are requirements.
Okay, great, thank you. But a PhD itself is a very technical tenure. You could see a PhD is very, it's a very specific topic in a very specific degree. So when you're doing it in chemical engineering, it is a given that you will be using a lot of technical skills, a lot of technical topics, core chemical engineering topics. And that is, of course, a given. That is something that you cannot ignore or reject. But having said that, at the same time, there is also a great deal for you to use a lot of soft skills that you don't necessarily get from the engineering part of the degree. If I was to ask you, what are the most important soft skills that you really need to have in order to achieve success at your PhD?
Okay, so I think, not sure if this classifies as a soft skill anymore, but project management, definitely. So in some universities, it's not taught, in some it's formalized, and more recently, our engineering council has prescribed it for all engineering disciplines. So that's something you need to build on as a PhD student. It's sometimes taken for granted that, this is just some simple topic and you'll eventually come into it, but it's more important to hone on those skills and schedule yourself and find out what resources you need before you get in. Very often, and for myself, I found this out much later, so many years down the line, that this is an important thing to work on before you get going, or at least at the very start of when you get going. The other thing is communication skills. I mean, definitely you need to be a good communicator, no matter where you are, whether as a student, a postgrad, or in the workplace. But specifically as a postgraduate student, you're going to need to be able to write down technical reports better than you were doing it in undergrad, or even in the workplace for that matter. And also, you're going to go for conferences, it's very likely. You're going to be presenting to a large group of people at some point, whether it's going to be for your proposal or when you're done with your work and you're presenting it to the department. So that's something you need to focus on as well. And generally, your people skills, that's something important as well, because as I said, it's not often the case you just get the resource, your equipment just for yourself. You need to be able to work with other people and share the space that you're working within. So, I mean, yeah, it's less so if you're doing a simulation or a paper-based project. It's going to be more important if you're sharing some kind of resource with other people.
Yep, fully agreed. You mentioned earlier that if someone was to go into it gets very difficult for someone to go into the industry and then coming back to the post-graduation or PhD, which is, of course, very much understandable. A lot of people are, because some students, they are very indecisive for what they want to do. They want to go into academia, they want to go into the industry. And the general talk of the town tends to be that if you go for a PhD route, you risk having you end up taking the risk that you will only be limited to academia and you cannot go to the industry later on. And you mentioned earlier that, of course, that one route of going from the industry to PhD, that tends to be very difficult. What do you think of the other way around? Do you feel that doing a PhD limits you to only academia, or have you seen recent professionals also going into the industry after a PhD?
Yeah, so more and more, at least in South Africa, we are actually seeing that. We're seeing more and more PhD graduates going into the industry. So whether it's as a consultant, a specialist, or sometimes they go on to completely different things as well. And I would say that the skills that you learn as a PhD candidate are extremely transferable. And most people will agree, in industry as well. And more we're seeing those in the C-suite, so your CEOs, CFOs, who have done some postgraduate study, and many of them even going back and doing their PhD. So I would actually say, yeah, it doesn't restrict you. Obviously, I mean, you will see your colleagues after your bachelor's going off making tons of money. And if that's something that you want, yeah, I mean, I wouldn't say academia is for you, even if you're just going to do your PhD and go on. But I mean, yeah, you will see that. You can't ignore it. It's not for those people. It is for people who want to further their study, who want to specialize in something, who are going to want that degree at the end of it. Yeah, so I mean, yeah, as far as being restricted to academia, no, that's not the case. Maybe it was a long time ago, but not anymore.
Perfect. Thank you so very much for that. But then if we were to talk about you, because you are also about to finish your PhD very soon now, and you are, of course, currently also doing your lectureship on the side. So what have you planned for your future? Do you wish to continue in academia or become a specialist in one specific topic, or do you see the industry will be the end goal for you?
So I don't think there's any end goal. I mean, just for myself, I enjoyed learning, and once I've learned as much as I can, then it just becomes boring at that point. So right now, I personally want to move out of academia and into industry. So that's the sort of route that I'm aiming for. I won't say that staying in academia and becoming a lecturer or even a researcher is a boring job at all. No, many people will say that you don't get the freedom that you do outside of academia. In academia, you get to steer research that you want, and although it's difficult, writing those grants and finding the funding to get things done, it is very rewarding. It's one of the most rewarding places to be in. But I mean, personally, I've wanted to be in industry as well. I think I've learned as much as I can about biobutanol, and that unfortunately, it's not the next big biofuel. But it's not. It doesn't dissuade me. So my specific goal is to go into industry for the short term. If I find, and I think I will find, that there's going to be a space for more research in that, whatever I do, then it's not going to be difficult to come back into academia.
Of course.
But yeah, I mean, for the short term, at least for the next 5 years or so, I want to see what industry is like, where that takes me.
Perfect. Great. Thank you. Now, because you are in South Africa, and you said in the very beginning of the interview that you have seen a great deal of decrease in the refineries shutting down, and the core typical engineering jobs to be going down and down in South Africa, and more people being interested in the non-engineering aspects. If I was to ask you very generally, do you think South Africa has good prospects for chemical engineering as of right now, if we talk about core chemical engineering jobs?
So I think I've also mentioned that the core engineering jobs were in mining or in the petrochemical space. So definitely in the petrochemical space, these are gone down. It's very difficult to find work in that sort of space. There is Sasol, which is, I think, the biggest employer of chemical engineers in the core petrochemical space at the moment, but even they are looking elsewhere for the company direction is moving more into the renewable space, or at least that's what they say for now. So we'll see where that takes us. But specifically for core petrochemical space, that's a no-go. The mining space is still thriving. There's a lot of opportunity to work there, especially in the management of old mines, where you get acid mine drainage, mines which have just been abandoned, and new processing technologies to look at how you can extract more resources from whatever was spent or whatever was waste at the time. So there is scope over there. But generally, and this is anecdotal, I feel like the industry for the core chemical engineering space has declined. It's much more difficult to find space there. And also, I think I also mentioned that, in my undergraduate degree, there were the options of the streams for pulp and paper processing. So that's also declined. Many of our mills for pulp production have declined, completely shut down as well. So that industry is declining as well.
Okay.
But to a smaller extent, the agricultural side, many of our graduates would end up in the sugar mills. That's also declining, unfortunately.
Yeah, but that is not a very good situation to be in, I guess, when all of your industries are. But that's not just South Africa. I would say, I guess, these industries are kind of decreasing in all around the globe, especially oil and gas. They are all the big companies now. They're moving towards renewability, or at least they're claiming to be moving towards renewability. But if I was to ask you, in your opinion, that now since you have named all these industries that are going down, someone who is graduating with a chemical engineering degree in South Africa, what industries should the students then keep their eye out for and should target those specific industries?
I feel that there is actually no limit to where a chemical engineer can go. Many of the traditionally, the traditional companies for taking commerce students, finance students, and so forth are looking more for chemical engineers. So the big banks, that's definitely a sink for many of our graduates. And the places like KPMG, for example, McKinsey, those consulting firms, even Deloitte or Ernst & Young. So traditionally where you'd have your accountants and economists, or economic students at least, they're taking more chemical engineers. So they're expanding more into the ESG space, so environmental, social, and governance space. And they want chemical engineers. So more so than they want their traditional, graduates. So I wouldn't say that there's less scope for our chemical engineering students. I would actually say there's more now, even with the declining core industries. It's still good to do, chemical engineering. Maybe not with the aim of ending up in chemical engineering space, but knowing at least that you will still work as a chemical engineer or process engineer in many different fields here. So. The prospects for that is not gone down, that's only gone up.
Do you think renewability is the next oil and gas sector in the world?
Well, that's a difficult one to say, especially because of electrification in the automotive space. So I think that's going to be one of the biggest things. Biofuels, there's a lot of controversy over there. In Brazil, for example, I think it's about 60%, depending on where you are, is ethanol. So that's biofuel as well. But underneath all of that, you don't see the rainforest being cut down to to facilitate the production of that ethanol. And in India as well, although they're increasing the amount of ethanol in their fuels, it's not, I wouldn't say it's something that one should focus on for the state of chemical engineering. In South Africa as well, it's very difficult to do that, especially since we have there's a great deal of water scarcity where the plantations are at the moment. So it's a very unstable industry. It's declining in general, across the world as well, as we see more of the effects of climate change. So I wouldn't say that's where people should focus on. However, that's not the only place where renewable fuels are. So in battery production, for electric vehicles, and now there's a lot of scope for hydrogen production, especially from your renewable sources such as photovoltaic cells, using that to perform hydrolysis, as well as wind power and those sort of things. There is scope over there. It's still a very early space to be in if you are there, but that's where we're going. So not so much in the petrochemical space, but more on that type of production. So more on manufacturing, more on research into electrification, hydrogen production, and less so on the biofuel space. There is still scope in the bioproducts space, the finer chemicals, things that can't be produced from petrochemicals anymore, and also things that can be produced, alternatively. Your bioplastics are increasing. We want more biodegradable plastics, so that's a space that's going to be taken up, but not so much the biofuel space.
Okay, perfect. That's very nicely put. Thank you, Muven. Then we'll move on to the time machine segment. Let's say that we could give you a time machine and you could go back to any time in the past to your old self, what would you tell yourself? One thing that you know today that you wish you had known back then.
So there's actually many things,
Mhm.
but I think one of the biggest disappointments, and it might have come across, is that biofuels are not the next big thing. At least liquid biofuels. It's very difficult to produce. It's highly controversial. And it uses too much water. At least that's what I found. So if I could go back and tell myself, don't do this, it would be, don't focus on trying to change the whole industry. Try and learn as much as I can. In the end, doing a postgraduate study is more about training. It's less about what you actually do. It's more about what skills you can get out of it.
Mm-hmm.
So if I had done my topic in something else, doesn't matter what it was,
mm-hmm.
afterwards, if I wanted to continue in academia or found a different topic, I could do that. Okay, in the same way, as I said, PhDs are wanted in industry and they generally thrive in industry. I would be taking those skills, doesn't matter what topic it was, into industry. So I could go back, I would say, don't focus too much on the topic. Mm-hmm. Do what I can get the most out of in terms of skills, and take it from there. And perhaps, with that knowledge, I wouldn't have, been demotivated by learning that you can't actually, I'm not going to be able to make biobutanol and replace all the petrol that we use at the moment. But I would have been much more motivated if I had known that I could do a different topic that maybe I'm more passionate about. Mm-hmm. Doesn't matter what it was, finish it at an earlier stage and move on.
Mm-hmm. Interesting. So thank you so very much for sharing that. Thank you. And then very last question I'll ask you for this podcast is, if you could share with us one skill, hard skill or soft skill, for future graduates that are about to graduate that you feel are the most important for going for the PhD, which one do you think that will be?
Just one skill.
One skill. If you had to pick one skill, and then what would that be?
I'm gonna go back and say the project management.
Okay.
Although it's a group of skills. Mm-hmm. It's project management as it's on itself, especially for your own personal work. That's a must. That's something that you need to focus on before you get into this type of space.
Okay, perfect. Thank you so very much, Muven. And that pretty much concludes all the questions we actually had for you for the podcast. And it goes without saying, thank you so very much for making time to partake in this podcast and for sharing your insights. It is truly appreciated, and we are very grateful that you could be here with us today. And we wish you, of course, the very best of luck for your PhD and for your future career. Thank you.
Thanks, Hamza. It was great to be here. You're a great host as well.
Yeah, thank you very much. Thank you.
Thank you for listening. And if you have not done so already, remember to become a free member at ChemEnggLife. And do not forget to like, share, and subscribe to our YouTube channel, and stay tuned for more upcoming podcasts with chemical engineers. Thank you, and have a great day.